Hello guys, today I want to share a sparkling project. So what you saw is one of the two features I created using a Broadlink device, which is a universal IR remote, and using it I am controlling the RGB lights that I have installed around my system. There is a Python module in between present, which is sending signal whenever there is a change detected to the lights. Everything is present in the GitHub with the README. So this video is about setting up your system and using it with your own RGB lights. There is no AI related stuff this time, but in future surely this setup will have an AI integrated in it. So do subscribe and don't miss that video. Intended audience would be someone familiar with command line, Docker, and some coding also. Although I have moved all configuration to a single file here like this, but patience and some coding is a plus here. I've created two features. One that triggers the light whenever there is a spike, and the color of the light will be what is the most contrasting color on the screen. And other is a TV backlight that syncs with the screen color. So let me show some demo first for motivation before continuing with this video. Don't quit just now. There are other demo videos hidden in between the video to keep the motivation high. Let me first talk about the device actually. It is a Broadlink RM4 mini that I am holding, costing around 2K on Amazon, and it can send IR packet as well as learn any device, like any remote IR packets. So why I've chosen this device, let me give you the reason is because it has this Python Broadlink SDK available. So this has enabled me to create the API to control this device. Let's now set up the Broadlink device. If yours is already connected to the app, then first reset it, since connecting to the app locks it for the third party usage. Okay, so step 1 is connecting the RM4 to the local network. For this, let's clone this repo. The link is in the description. I have already cloned it here. And then let's go to the scripts folder. So we here have a helper script called setup-device.py. For this, we first need to put our device in AP mode. So long press the reset button and then connect to the broadlink device. So it would be available in here. After that, what you have to do is run this script with the Wi-Fi name and password like this. Here, that python setup.py and the ID of your Wi-Fi and password of your Wi-Fi and security set to 3. So only connect with 2.4 gigahertz band since that is supported in RM4 mini. If you are using some other device, then check what band it supports before connecting to the local network. Once it is connected to the local network, then we can hop on to the next step. We are now ready to run the API. Let's first build the Docker container using docker build -t and the name as broadlink API. So you have to be in the base folder first, okay, and then run this docker build command. Wait for some time since I already built it, so for me it will take less time, but for you it might take around 4 to 5 minutes depending on your system. Once the build is finished, we can now run the Docker container, but before that there are actually two ways to discover our device in the API. So the first one is using the IP address that requires all these environment variables to be present, and the other is using the device name, which only requires this, that is the device name environment variable, but it also requires network host network flag to be host. So Linux support both these two methods, but Windows only support this. So currently we are using Linux systems, so I am running the Docker using this. And to get all these environment variables, we can use our script helper actually. This get device info and run it and wait for some time. Also note that you must be connected to the same network that your device is connected. So here are all the information. So now we are ready to run our Docker container. So this is the command, and this I have put the device name, the name of my device, and run. So the APIs is now running. So let me show you how it works. So I have opened the Postman, and here is the send packet endpoint. This is the Docker container that we created, and the packet here is set to the information that will turn on the light. So let me send the request, and here the light is turned on and here off like this. So for the first time this might take a little while since the device is initialized. After that it is spontaneous, taking milliseconds. Now let's configure the RGB lights. First we need to learn the whole remote actually, and it's a time taking process. So here's a Tron movie demo for staying up to this point.
You got no chance, user. Their butts are faster than ours. Use the levels. Now this I can do.
Okay, so after the refreshment, let's see how we can store the remote. And here I'm opening the Postman, and I will hit this learn endpoint, which is a get request actually. So when I hit this learn command, the device goes into the learn mode and this light will be turned on. So now when I'll point the remote to it and press a particular button, that particular code will be learned. So for example, I'm using this remote and pressing this on button. Okay, so the postman has returned the value. Let's switch to the other camera. So here we have the packet and we can copy it. Now let's paste it to the send packet endpoint that we have already seen. So when I send a request, the lights on my tables turn on. Mapping of the command to the packets, you have to do it for all the buttons and make a configuration like this. So this configuration is in config remote code.json. So actually this repo, let me show you what this repo is. You have to clone, the link is already in the description, and you have to clone this repo. This is the RGB light controller repo, and I've already cloned it. Once you cloned it, go to the open this repo in VS Code or other editor, then go to the config remote code.json, and in here you have to create a configuration like this for your device. So the device name can be anything, but the key should be same. The value you can take anything. The max brightness is actually the brightness up to from the lowest level, the max brightness that your RGB light supports. So you have to go to the lowest level and then press the up brightness button until there is a change in brightness and count that number. So for my device it was 6. Now I have already shown you how that learn command works. So you have to do it for every button. Like here I have done for on, then off, then red, then green for all the lights. This is for one device. Then for the other device also I have done. Let me show you. This is the second device, monitor backlight. Here the max brightness was different, and here also on, off, increase brightness, decrease brightness, then red, green, blue, yellow 1, yellow 2, like this. You can give the key anything, but the value should be the ones returned by the learn endpoint. Now after the mapping is done, you have to create this color mapping as well. So for that, what you have to do is that for each color that your RGB supports, you have to find the most appropriate RGB tuple for it. So for that, what I did is to turn off all the lights in my room and then press each color button, then go to the RGB picker and match the one that most appropriately matches with the RGB color. So the best you do it, the more synced color will be with your screen color. So like, do it with precision. Now we are ready to run our spike and the backlight feature. So for that, simply create the environment and then install all the dependencies, that is pip install requirements.txt. So I've already created the environment and installed the dependencies. After that, what you have to do is there is this light manager in both this run backlight feature and run spike feature. So like, let me show you in the spike feature. The light manager is a class. In this you have to give the device name, the name that is in the remote code config.json, the exact same name you have to give, and the initial brightness, like just you have to do this much to create your light manager, and then pass it to the spike light. Similarly, for the backlight also you have to create this light manager with same device name and initial brightness, and then pass it to the light manager. So by this you can actually run on these two features. And also there is this config.json that you can change according to your need. So for like the for the spike monitor, there is this sample rate, chunk size, spike threshold. Like if you have a noisy room, you can increase this threshold. If you have a quiet setting, you can decrease this threshold. And the channels of your microphone. Then here is the screen monitor config. So the display ID is actually, if you have multiple displays, then you can choose what display that you want to sync your RGB lights with. This save images is actually for testing. This will show you the images that have been captured. Then in the backlight config also there is this interval. So actually set this interval to something like 1 second or 5 seconds to make the backlight sync more smoothly actually. And this save image is again same as this. So now you can just simply run python run backlight feature.py or spike feature.py, and that will run the feature with your light monitor. And so before I end this video, here's a Batman movie demo for you all.
Okay, wrap them up. Wrap them up, wrap them up, wrap them up. That's not good. Okay, that's not good.
I know this code can be improved a lot. Therefore, the repos are public, and I invite you all, the viewers, to contribute their ideas in future. In future, also, I am thinking of integrating the LLM in some useful, fancy way. So, stay tuned, subscribe, and bye for now.